Guys, welcome to Word Academy, and in this video we are going to continue on geometric progression. So it's about geometric progression. So sometimes which is called GP. So that's geometric progression. Now, in this specifically in this video, we are going to look at the geometric mean. Then you also look at sum of the terms, and then also sum to infinity. So sum to infinity. Okay. So these are the outline for today's video. So for those of you who are watching us for the first time, please, we are kindly asking that please subscribe to our channel so that we can keep on uploading this kind of videos. So this is the second part of the video, by the way. So part 1 is already out, so please check it out. So in this case, we are going to look at geometric mean. So what we mean by geometric mean is that under geometric mean, okay, what happens is that if you have two or three numbers, for example, A and B and C, so the mean of this number, the average, you discover that it is going to be B. So the geometric mean of this B will be given by B squared is equal to the square root of these two numbers. So you have A multiplied by C. So meaning that this, you can have the square root so that you cancel that one. And then you're going to have B is equal to the square root of A multiplied by C. So for example, if I have if A equals to, let's say A equals to 1 and B is equal to 25, for example. So what this is going to be is the geometric mean of this, this is C, okay, so A and C. So the geometric mean of these two numbers is going to be B equals to the square root of 1 multiplied by 25. And this is going to give you square root of 1 times 25 is actually 25, which is just 5. Okay. So that's how you can go about the geometric mean of two numbers. Okay. Now we are going to look at the sum of the terms. Okay. Now under the sum of the terms, there are two things that you need to understand. So check if r is greater than 1 or if r is less than 1. So you have two conditions there. So for example, given that you have these two numbers, 5 comma negative 10 comma 20. So this is an example that I'm keeping constant, the one that I did in part 1. This is the example that I have. So we are going to say find the sum of the first three terms. Okay, so find the sum of the first three terms from this one. So the first thing is to find the ratio, common ratio R, which is negative 10 divided by 5. And this is just the negative 2. So for those who watched my video, this was provided earlier in part 1. Please check it out. So now you check, is our R greater than 1 or is it less than 1? Okay, so we know that any negative number is less than 1. So our R is less than 1. Okay, so there is a formula that we must be able to apply. So then sum of those numbers is going to be the first term multiplied by the 1 minus R to the power n, close the bracket, divided by 1 minus R. So in this case, we know that our n is 3, this one, and our R is just negative 2. So from there now, a sum of three numbers, okay, will be equal to the first term. The first term from this sequence is just this first number. So that is the first term. And this is going to be 5, open bracket 1, minus, then open the bracket, this one, negative 2, to the power n is 3, close the bracket, and then over 1 minus, open bracket, negative 2. Okay. So from there now, S, sum of three numbers, where S stands for the sum, and this is just going to be this, then 1 minus, then this is negative 2 to the power 3 is just negative 2 multiplied by negative 2 multiplied by negative 2. And this will give you, this is positive 4, and times negative 2, this is negative 8. So this one is going to be negative 8, close the bracket, and this one positive, negative times negative, we are going to have plus 2 there. So from there now, going to have this one as 5, open the bracket, negative times negative, be just 1 plus 8, okay, then over 3. Okay, so this one we can extend there, is 5 multiplied by 9 in the bracket there, then divide by 3, which is just 5 times 9 is just 45. Okay, 5 times 9 is just 45. So 45 divided by 3, which is just going to give you 15. So what this implies that if you were just to add these numbers, okay, if you are just to add these numbers, okay, so 5 plus negative 10 plus 20, okay, so this is going to be 5 minus 10 plus 20. Okay, and this is going to give you negative 5 plus 20, which is just 15. So just like adding all these numbers together, and in this case you get this number. Okay, so now that's all you need to understand about this one. Now the last one is let us go to sum to infinity. So there is a formula that you must be able to understand when it comes to sum to infinity. So when you're looking at sum to infinity, we use the symbol S, and this one equals to the A1 divided by 1 minus R. Okay, so if in our case, in this case our A is just 5, A1, and our R is equal to -2. So this is just an example so that you are able to see how you can apply this. So now sum to infinity is just going to be 5 divided by 1 minus open bracket negative this, and this is going to be 5 divided by 1 plus 2. Negative times negative, you get positive, and this will just give you 5 divided by 3, which is just 1. Okay, so 3 into 5, that is 1, remainder 2, and it's remainder 2 over 1. Okay, so that's how you can just apply the formula when the question asks you to find sum to infinity. Now, what do you need to understand now is that we need to, so your homework, so your assignment is go and solve 2022 paper 2 mathematics. Okay, paper 2 GCE. Okay, so go and solve this one, and it is on question 2B. Question 2B. So make sure you go and solve that by just following what you have done here. Now, for your own information, remember that this is the formula when R is less than 1. So when R is greater than 1, what you just need to do is just to say sum of those terms equals to A1 open bracket R to the power n minus 1, and then also just the R minus 1. Okay, so this is for R is greater than 1. Okay, so make sure that you understand that. So thank you so much for watching, guys, and I'll see you in the next video. This is Evad Kokadin. It's bye-bye.